You have an existing Kubernetes cluster, you have a microservice architecture, and you're interested in a service mesh. In this video, we're going to be taking a look at a service mesh called Linkerd. In our architecture, we have a video HTML website. It's exposed via an Ingress controller on servicemesh.demo/home. When it loads up, it makes a call to the playlist API. Also exposed by an Ingress controller over servicemesh.demo/API/playlists. The playlist API retrieves the playlists from a Redis database. For each video in the playlist, it calls the videos API, which is a private service in the cluster. It has its own Redis database. After the playlist API has retrieved all the videos from the videos API, it sends the JSON data back to the videos web, which renders it in the browser. So in this video, I'm going to show you how to add Linkerd to your existing Kubernetes cluster, and then cherry pick features that I believe might be valuable to you. Linkerd is very subtle, discreet, and one of the most least invasive service meshes out there, which means you can install it with ease and easily remove it, and easily opt in and out of certain features and add it to certain microservices. So I'm super excited, and we have a lot to talk about. So without further ado, let's go. So if you're new to service mesh technology, I've made a video which is a subtle introduction to service mesh and service-to-service communication. The link is down below, so be sure to check that out. In this video, if you take a look at my GitHub repo, I have a Kubernetes folder, and in there I have a service mesh folder. And in the service mesh folder, I have a Linkerd folder with a README. This is a README that shows you the introduction to Linkerd with all the steps and examples I'm going to show you guys today. So be sure to check out the link down below to the source code so you can follow along. So the first thing we're going to need is a Kubernetes cluster. Now in this demo, I'm going to use a product called Kind, which is used by the Kubernetes community to build and test Kubernetes in Docker containers. So to do that, I'm going to say Kind create cluster. I'm going to call it Linkerd, and I'm going to run a Kubernetes cluster with 1.19. So this will go ahead and spin up a one node Kubernetes cluster with Kubernetes 1.19 in a Docker container. So now I can say kubectl get nodes, and we can see we have a one node Kubernetes cluster ready to go. Now the user will open up the browser and go to servicemesh.demo/home. This will load a bunch of playlists with videos in them. So to show you the architecture, when the user opens up the browser and hits servicemesh.demo/home, the request will come to an Nginx Ingress controller, which will then be routed to videos web. That's the page we're seeing in the browser. It has a list of playlists with videos in them. When this page loads for the first time, the browser will make a call to servicemesh.demo/API/playlists, which is a GET request to the playlist API. This will come from the browser to the Ingress controller and go to the playlist API. The playlist API will retrieve the playlist data from the playlist database. This is a Redis instance running inside of the Kubernetes cluster. It retrieves the playlists from Redis, and for every playlist it receives, it makes a private call to the videos API to fill out all the video data and video content, like the title, the thumbnail, and so forth. Remember, the playlist API has no domain knowledge about video content. Since it's a microservice and only knows about playlists, it has to ask the videos API for video content, and the video API has its own database. Once all the video content is sent back to the playlist API and the full playlist has been retrieved, it is sent back to the browser for rendering. The explanation of this full architecture and every component is documented in my GitHub repo under Kubernetes Service Mesh in an introduction README file. This introduction talks about every single component, how it all works, the traffic flow, the full architecture, as well as how to run it with Docker Compose. So you can say Docker Compose build, Docker Compose up, and access it over localhost. And also how to run the full architecture in a Kubernetes cluster, which we're going to do today. So to deploy all these applications, and starting with the introduction to Linkerd, we have created a Kubernetes cluster. The next step is to deploy our microservice architecture. And the first thing we're going to do is create a new namespace for our Kubernetes Nginx Ingress controller. And then what I'm going to do is say kubectl apply and apply my Ingress controller manifests. That's going to go ahead and deploy the Kubernetes Nginx Ingress controller to that namespace. And then I'm going to apply all the manifests for these applications. So I'm going to deploy the playlist API, API, the playlist database, the videos API, the videos web, and the videos database. So to do that, I'm going to copy paste all these kubectl commands to the terminal, and that's going to go ahead and apply all the YAML files. If you're interested in the YAML files, you can head over to the Kubernetes folder, service mesh, applications, and you can see all the applications are separated out here. And to make sure all our applications are running, I can say kubectl get pods, and we can see they're all up and running. We also want to make sure our Nginx Ingress controller is running, so we say kubectl get pods on that namespace, and we can see we have 2 Nginx Ingress controller pods ready to go. Now for this demo, because we don't have a real DNS, we probably want to fake a DNS name. So if you're running Windows, you can open up C, Windows, System32, drivers, etc, and open up your host file using administrator right, and you can add the following entry into the host file. If you're running Linux, you can edit the etc host file as well. Now to access our Nginx Ingress controller, I'm going to open up a new terminal, and what we're going to do is we're going to port forward to the Nginx Ingress controller on port 80, and that's going to go ahead and connect to that so that we can open up services.demo in the browser. And if we open up the browser, we can say servicemesh.demo/home/ and we can see all the playlists have been loaded with all the video content in them. If you press F12 and you open up the developers tools, you can open up the network tab. You can go ahead and refresh this page, and in the network call you should see a playlist call being made. So you can see the browser loads up and fires a request to servicemesh.demo/API/playlists, and this gives us all the data that we're now seeing in the browser. Now the next step for us is to go ahead and download and install Linkerd. Now this is just a personal preference, but for demo purposes, I like to install everything in Docker containers. That allows me to isolate all these things that I need to install inside of a container, and I can throw it away when I'm done. So to do this, I'm going to run a tiny Alpine Linux container. I say docker run -it. I mount in my home directory because that's where my kubeconfig is to access my cluster. I also mount in this working directory, so I mount this entire Git repo into a folder called work, and then I set that working directory to work. I also run this in host networking so we can access the host network, and I give it a shell terminal. So that'll open up a terminal. Now I'm inside the container and I can get to work. So the first thing is I'm going to install curl to download Linkerd, as well as nano, which is just a lightweight text editor. And the next thing we're going to need is kubectl. So I'm just going to say curl, and I'm going to pull down the latest version of kubectl, give it execution rights, and move it to user local bin. So I go ahead and run that. That's going to go ahead and download kubectl, move it to local bin, and now I can say kubectl and it's installed, ready to go. I can also set the default kubectl editor to nano, and to test whether everything works, I can say kubectl get nodes, and we can see we have access to our Kubernetes cluster. I can also say kubectl get pods, and we can see our full architecture is running in our Kubernetes cluster. And the next thing we're going to need is Linkerd CLI. So to download Linkerd, you can head over to the GitHub repo onto the releases page and just download the binaries from there. So on the Linkerd GitHub repo, we're going to be downloading the Edge 20.10.1 version. You can go ahead and grab the binaries from here, or you can just use curl to download it directly. So I'm going to say curl, and I'm going to pull that binary from the releases page from the download section. When that's downloaded, I'm going to give it chmod execution rights, and I'm going to move it to user local bin. And then I can say linkerd -help, and we can see it's installed and good to go. So the Linkerd CLI has this great ability to check compatibility with your cluster. This is great to ensure that your cluster is suitable for the mesh, whether you're running the right version of Linkerd with the right version of Kubernetes, and it'll tell you what is incompatible with the mesh. So to run these pre-flight checks, I can say linkerd check --pre, and this will go ahead and check a whole bunch of stuff in the cluster and give us a full report. So it tells us whether it has Kubernetes API access, the right version of Kubernetes. It does a bunch of pre-Kubernetes setup checks. So you can see here, it's also warning us that we have a bunch of v1 beta API extensions that's going to be deprecated beyond Kubernetes 1.22. It also checks a bunch of creation permissions. It checks capabilities, as well as the version of Linkerd. So what I like about the Linkerd CLI is every version of the CLI will generate the manifests for that version of Linkerd. So to install it, you just say Linkerd install, and it will go ahead and spit out all the YAML files and manifests that's needed for that version of Linkerd. Now to see the manifests that it outputs, I can say Linkerd install, and I can send all that output into a file. So I created a file on the left here called Kubernetes service mesh Linkerd. Under the manifest folder, I'm going to output the YAML there. So when I've done that, we can see on the left here, we have Kubernetes service mesh Linkerd manifest, and here is the YAML file right here. This has the namespace, the RBAC roles, all the deployments and permissions, config maps, and everything we're going to need to deploy and get Linkerd up and running. And to go ahead and install that manifest, I then say kubectl apply, and I apply that YAML file to my cluster. That's going to go ahead and install all the Linkerd components inside the Linkerd namespace. I can then say watch kubectl -n in the Linkerd namespace for get pods, and we can see all the components for the Linkerd control plane is now coming up. And after a minute or so, we can see all the pods in the Linkerd namespace are now up and running. So our Linkerd control plane is good to go. I can then do a final check by saying Linkerd check, and it will go ahead and run a check against that control plane to make sure everything is configured, everything exists, and it's all good to go. Some of the things that I like the most about Linkerd is the great user experience. It has some of the best user experience and documentation I've ever seen. It's extremely easy to install, and it's one of the least invasive and intrusive service meshes out there. All of this YAML I've just showed you deploys itself in its own isolated namespace, meaning it doesn't go ahead and tamper with your existing cluster. It doesn't go ahead and change a bunch of stuff. This makes it easy for us to cherry pick features we want, and we can turn on certain services to become part of the service mesh. And if you decide you no longer need a mesh, you can simply uninstall it. So if we head over to the Linkerd architecture documentation, we can see Linkerd has a very simple and well explained architecture. Linkerd has this concept of control plane and data plane. All of these pods we've just deployed basically form the Linkerd control plane, and everything we add to the mesh basically becomes the data plane. So we'll have our applications running and the Linkerd proxies that will be injected into those applications to form part of the mesh. This is what forms the data plane. So the data plane is pretty much where all our apps run, and the control plane are all these pods that you can see up here that we've just deployed. So let's go over the architecture. So you can see there's a Linkerd web pod, and the Linkerd CLI as well as this web pod talks to the public API, which is basically this Linkerd controller pod over here. We'll take a look at the Linkerd web dashboard in a second. And then we have this Linkerd tap pod over here, and this provides this tap component, which is a tapping feature in service mesh which allows you to tap into service-to-service communication. I'll show you more of that in a bit. Then we have the Linkerd destination pod, which is basically this component over here, which all Linkerd proxies interact with. Is basically a lookup service that tells the Linkerd proxies where to send requests. Then we have the Linkerd identity pod. That is the identity component over here, which is basically the certificate authority and provides certificates for mutual TLS between all pods that are part of the mesh. Then you have this proxy injector over here, which is running right here, and this is the guy that's responsible for injecting proxies into the application pods. Then you have the Linkerd SP validator. This is the service profile validator, and in a bit we'll take a look at what service profiles mean. Linkerd also deploys its own Prometheus and Grafana version, which is going to give us metrics for all the pods that are part of the mesh. So to access the Linkerd web dashboard, we can simply run port forward, and we can run kubectl in the Linkerd namespace port forward to the Linkerd web service on port 8084. Then we can open up the browser, go to localhost 8084, and this will lead you to the Linkerd dashboard. The first thing you'll notice is that it has quite a nice overview of namespaces, the control plane, and all the workloads running in your cluster. And it allows us to get a view of HTTP and TCP metrics over namespaces, cron jobs, daemon set, deployment, jobs, pods, replica sets, replication controllers, and stateful sets. We can see all our namespaces here, and this allows us to drill down into the namespace, and we can see deployments and pods, replica sets, all listed here. We can also drill down into namespaces, so we can go into our Ingress namespace, and we can see our Ingress controller also running here. We can also see things like traffic split, tools like tap, top, and routes, and we'll cover those in more detail in a bit. Now the first thing we need to talk about is the concept of meshing. Now you can see here, if I select a namespace and I can drill down into a namespace, none of our services are currently meshed. Now meshing is a feature that allows a specific pod or a deployment to become part of the service mesh. By default, none of your pods will be affected, and you have to manually opt in for your service to join the service mesh. Now when a workload wants to become part of the service mesh, Linkerd will then inject a proxy as a discrete sidecar into every pod that's part of that workload. At that point, that service will become meshed and it will show up in our dashboard over here. So if you look at the dashboard on the namespaces section, none of the namespaces are currently meshed other than the Linkerd namespace. Now there's two ways to add a pod to the mesh. If we do kubectl get deploy playlist API, we can see we can return an object from kubectl. And the other feature that kubectl has is to say type O YAML. That will output this deployment as a YAML file, as you can see here. Now what Linkerd allows us to do is Linkerd can grab this YAML file and inject the proxy into the YAML file. So we can say kubectl get deploy output as YAML and then pipe that guy to Linkerd inject. And when we do this, we can see now that kubectl takes the YAML out, passes it to the Linkerd CLI, and the Linkerd CLI will add the small annotation onto that deployment. So you can see it says template metadata annotation linkerd.io/inject enabled. This is all you need to add a deployment or a cron job or a daemon set as part of the service mesh. So to show you again, I can say kubectl get deploy output as YAML, pipe it to Linkerd inject, and then pipe that result to kubectl apply -f. That'll go ahead and pull the YAML out using kubectl, send it to Linkerd command line. Linkerd will inject the annotation and then we'll take that output and pipe it into kubectl apply. This will manually inject the annotation into our deployment and allow it to become part of the mesh. So if I go ahead and run that command, we can see it injects, and on the left here we can see it's automatically now spinning and it's becoming part of the mesh. Now you can see the playlist API is 1 out of 1. It's fully meshed, so it's become part of the Linkerd service mesh. So the thing to note here is that we've just manually injected that annotation into our deployment. So if you're using something like GitOps or a CI/CD pipeline, you probably want to put that annotation on your deployment. Otherwise, your CI/CD will override what we've just done manually. So the Linkerd inject command is a great way to temporarily just add your deployments to a service mesh. But if you want to do it permanently, you'd have to go to your Git repo where your deployment file is. So in my example, I have Kubernetes service mesh applications folder. I can go to something like the playlist API deployment.yaml and I can go to template metadata annotations and I can add this Linkerd inject enabled annotation. That means when I deploy through something like Jenkins or Flux or Argo, it'll automatically stay part of the service mesh. So what I'm going to do is I'm just going to run kubectl get deploy on all my deployments and I'm going to pipe all of them to the Linkerd inject command and apply them back, including the Nginx Ingress controller. So I'm going to go ahead and paste that to the terminal and we can see all our services will form part of the mesh. If we take a look at the mesh here, we can see all of them are now joining up and you can see all my deployments are now meshed. So it all works via the annotation, which makes it easy if you want to opt out of the mesh. You can simply go and remove this annotation from your deployment and just apply it back to the cluster. Now it's also important to note that when you change the annotation on a deployment, Kubernetes will roll out new pods for that deployment. So we're going to have to close and open that port forward to our Nginx Ingress controller once again, and then let's go ahead and open up a new terminal. And what we're going to do is generate some traffic to our application. So what I'm going to do is I'm going to run a PowerShell while loop that's just going to run and form a curl request to the servicemesh.demo/home endpoint. And it's also going to simulate the call to the playlist API in a loop as the browser would. And it's going to do this every second. So I'm going to go ahead and copy paste that to the terminal, which is going to start generating some web traffic to our application. Now, if we go to the Linkerd dashboard, we get a pretty nice ivory table tower overview of namespaces in the cluster. So we can see we've meshed our default namespace, and now we can see things like success rates of HTTP metrics, the requests per second, 50 percentiles, 95 and 99 percentile latencies. And if we go into the default namespace, we can see the playlist API is making requests to the videos API. We can also drill down now into each deployment, so we can see the playlist API, playlist database, videos API, videos database, and video web all meshed. We can see the success rate is 100% across all of them. We can see requests per second as well as latency metrics. And we can also drill down into the playlist API, and we can see that the playlist API is sending requests to the videos API. And we can also see that there's a fan out because there's very low requests per second coming in and 7 requests per second going to the videos API. So the playlist API makes a bunch of requests to get video content. If we scroll down, we can also see live calls. So we can see live traffic going to the videos API. You can see the counters are incrementing over here. You can see the best and worst and the last latency as well as the success rates. We can also see that all the traffic is coming from the Nginx Ingress controller. So the browser is making a request to the Ingress controller, which is forwarding it onto the playlist API. The playlist API then fetches all the video content from the video API, as we can see here. And if we go back, the cool thing that you can see here is that every single deployment has a link to a Grafana dashboard. So if you click into that, this will take us to the Grafana instance running in the Linkerd namespace. And this gives us a bunch of black box metrics for all the pods that are part of the mesh, regardless of the programming language that we've used. The cool thing about it is I've had to add no code to any of my applications. So I get all the stuff out of the box by just meshing my pod. So we can see success rates to the playlists API, the number of requests per second. We can see the inbound deployments as well as outbound deployment. The outbound here is our videos API. We can see inbound traffic. So this is all the traffic coming in from the Ingress controller, and the outbound traffic. So this is all the outbound traffic going to our videos API. It also describes the outbound deployment here in detail as well. So we can go down and we can see the success rate to the videos API, the request per second, as well as the latency. So this is very impressive. The service mesh gives us direct links into Grafana dashboards with live telemetry for request per second and latency percentiles. No matter the programming language we use, we don't have to change a single line of code in any of our services. All we need to do is add an annotation to our deployments and have our pods join the service mesh. So now we see that Linkerd gives us these great observability and latency and request per second metrics out of the box. But let's pretend the development team commits some buggy code to the videos API. How can Linkerd and all this metrics help us detect faults within our network? So what I'm going to do is I'm going to go ahead and edit my deployment. I've added some buggy code to the videos API, which I can enable with an environment variable. So I say kubectl edit, I edit the videos API deployment. And if I go down to environment variables, we can see that we have this environment variable called flaky. And I'm going to go ahead and set that to true. That'll go ahead and roll out a new videos API pod, which will have some buggy code in there. Now we go back to our namespaces and we notice that the default namespace has a 92%, 91% success rate that keeps going down. And if we drill down into that, we can see the playlist API has a 42% success rate. The videos API has a roughly 87% success rate. So with this observability, we know now that there's a very low success rate between these two deployments. We also know that the playlist API makes requests to the videos API. So firstly, let's jump into the playlist API and see what is going on. We can see both of them have very low success rates. And when we take a look at this deployment and we scroll down to live calls, we can see the live traffic going to the videos API, and we can clearly see here that there's a low success rate for requests going downstream. And we can also see that the calls coming in from the Nginx Ingress controller has a very low 0 success rate. So we can see that there's a problem with the playlist as well as the videos API. So we can see there are network problems between the Ingress controller, the playlist API, and the videos API. Before we make assumptions on where the problem is, let's see if we can use Linkerd's tap functionality to tap into the network to figure out where the problem lies. Now tap is a feature that allows us to listen to traffic streams for a given resource. So we can listen to network streams between pods in the service mesh. Now you can either use the command line and run Linkerd tap command on a deployment, or you can use the dashboard. So we can go into the playlist API and we can look at these live calls, and there's a little icon here that allows us to tap the requests. Or we can go to tools, click on tap, find the resource, in our case it's the default namespace, and we can start with the playlists API and we can say start to tap. It'll also give us the command we can use in the terminal if we prefer to do so. And let's leave this running for a couple of seconds and let's stop. And what we can see here, which is very interesting, all requests coming from the Ingress controller are all just spinning. It means it looks like they're timing out. And if we look at the downstream, the playlist API we know is making a call to the videos API, and we can see here that it's getting 200 HTTP success codes, but it's also intermittently getting 502. And if we take a look at Google, what a 502 error means, it basically means that we've received an invalid response from the upstream server. So that means we're getting an invalid response from the videos API. So it's starting to become more clear that the problem lies with the videos API and the way it responds to the upstream. Now this is a pretty clear example of a cascading failure in a microservice architecture. Now the team who's responsible for development of the playlists API is not handling these invalid responses coming from the downstream server. The team who's responsible from the videos API have checked in some buggy code. So now that we've identified a problem, the team who's responsible for the videos API will go and have to do a bug fix. So we can see that Linkerd gives us this great overview and insights of what is happening on our network. Now I briefly mentioned the concept of service profile. So let's see how a service profile can help us to tell Linkerd how to handle requests for a given service. Now Linkerd allows us to use this concept of service profiles. Basically, it allows us to tell Linkerd how to handle requests for a service. Now there are a few ways we can generate this service profile. We can either use a Swagger, protobuf, auto create, or a template. So I'm going to show you the auto creation and template mechanisms, which is the easiest way to generate a service profile. So we can auto generate a service profile using the auto creation method. We can say Linkerd profile, and we can profile in the default namespace. We want to profile the videos API service. This will profile all traffic for this guy, and then we'll say tap the deployment, and what we're going to do is say tap duration for 10 seconds. So this will run the Linkerd tap command on this deployment and generate a service profile template for us. So we can see it's created this YAML output for us, which is basically a service profile. And during the time it tapped the service, we can see it's received all these different GET requests. So what I've done is in the Kubernetes service mesh Linkerd folder, I've created a service profiles folder and a service profile YAML for the videos API. So I'm basically going to take all of this YAML we see over here, I'm going to copy it and I'm going to paste it into this file. And what I'm going to do is I'm going to remove these extra conditions that we have here for these extra requests, and I'm going to name this guy get all, and instead of just getting a single request, I'm going to target all requests. So this is a regex, so I can just say .star. This will target all get requests coming to this video API. And now the service profile allows us to set up things like retries, timeouts, and retry budget. So we can do auto retries and a bunch of cool things with the traffic coming to this API. So we know that the failures to this video API is intermittent, so let's go ahead and configure auto retry. So Linkerd has great documentation on configuring retries using the service profile. So we've answered the questions already about which services we want to retry on, and we want to know also how many times should we retry the request. So adding automatic retry is quite simple. We just have to add this is retriable field to our service profile spec. So if I go to the service profile spec, we can simply add this guy to here, and that means that this service profile will tell Linkerd to retry all connections coming into the videos API. So after creating the service profile, we can go ahead and apply it using kubectl apply. I can go ahead and apply that YAML file, and that'll go ahead and create the service profile. And to see the effects of that service profile, we can use the Linkerd routes command, so we can run it on the default namespace on the deployment of playlist API to the service videos API. And this will print out all traffic going between the playlist API and the videos API. So we can see that there's a 100% effective success rate now. So the customers are getting 100% success rate, although the actual success is only 70%. So that shows us that the proxies between the playlist and the videos API are retrying the connections. And we can see that the effective RPS is 7 requests per second and that the retry is 11 requests per second. So there's extra requests going out of the playlist API to the videos API for auto retry. And if we hop back to the Linkerd dashboard for deployments, we can see now that the playlist API has fully recovered. So it's retrying connections to the videos API. So now the customers are not getting any impact. And I can go ahead back to my browser and I can confirm this by refreshing the page, and we can see we don't have any downtime now. So by configuring auto retries, our playlist API is now retrying the connections to the videos API, which has temporarily fixed the problem for us. Now it's important to understand the effects of automated retries. Too much retries can put a lot of extra strain on the network. Now Linkerd allows us to configure retry budgets as part of the service profile, so we can define a fair balance between not too much retries and just enough retries to solve these error rates. So we can confirm this extra network strain by running the Linkerd routes command, and we can see that there is effectively 7 requests per second, but the actual request per second is 11. So there's a lot of extra requests coming out of the playlist API and hitting the videos API. Now, although the latency percentiles may seem low over here, if we go to the dashboard, we can see that the playlist API latency percentiles are much higher than they used to be. They used to be roughly 10 milliseconds, and they're now almost up to 40 milliseconds. So you can see the overhead of when adding too much retries. Now, we can change our service profile YAML to include a retry budget where we can add retry ratios, minimum retries per second, and a TTL, and then run the Linkerd routes command again to monitor that overhead and tweak the service profile accordingly. Now, the other cool thing about adding our pods to a service mesh is that we get mutual TLS between all these microservices that are part of the mesh. That means the traffic between the playlists and the videos API is automatically encrypted with mutual TLS, even though my code base thinks they're talking over port 80. So I don't need to add any code and I don't need to rotate certificates myself. Now, to confirm this, we can run the Linkerd edges command on deployments in the default namespace, and we can see that all of these pods are secured. So the source is the playlist API to the videos API is secured. We can also verify this using the Linkerd tap command and run tap command on the deployments. And if I do this in the default namespace, this almost looks like a TCP dump command. So if I run this for a couple of seconds and hit Control-C, we can go ahead and look at all these requests, and you can see that they're all TLS equals true. So we can see here's a clear example of a request going to our videos API from the playlist API, and it has TLS true on it. So this shows us that all the traffic between the playlist and the videos API is encrypted with TLS. Now, I know that was a ton of information about getting started with Linkerd, but I hope you were able to absorb all of that information. Be sure to check out the link down below to the source code and follow along and try it out. And let me know down in the comments about your service mesh experience. And in the next video, we'll be taking a look at slightly more advanced topics such as canary deployments and tracing. And also remember to let me know down in the comments what sort of features and topics you'd like to see in the future. Remember to like and subscribe, hit the bell, and check out the link to the community server below. And if you'd like to support the channel further, be sure to hit the join button and become a member. And as always, thanks for watching, and until next time, peace.